Assalamu alaikum wa rahmatullah. Today I'll be revising with you the Demography and Vital Statistics lecture. Throughout this lecture, I'll be reading the slides normally and then focusing on the equations since there's plenty of them here. Throughout our reading, I will be transferring these equations into this other note here that's clear under the name of Demography and Vital Statistics Equation Collection. At the very end of this session, I will be sharing this with you, inshallah. Anyways, let's start here. Demography is the science concerned with the study of population. Within the science, the following subjects are discussed: census, fertility indices, and population growth and overpopulation problems. Here, census is the process concerned with enumeration of individuals all over the country at certain time, collection of demographic and socioeconomic data of the population, which include age, sex, nationality, religion, etc. The data is collected by filling in a special census sheet by head or a member of the family or trained persons. Census information is collected repeatedly at periods, usually every 10 years. So basically, census in Arabic is called Ta'dad Sukkani. It's where we are concerned with collecting the number of people at a specific point of time, and then also like talking about their like religion or their gender or their nationality, age, etc. That's basically what's the whole process is. And then uses of census is to give characteristic features of the population and to provide the needed data to calculate statistical rates and planning of different community programs like educational, health, socioeconomic, and others. Okay, census population and estimated population. Census population means the number of the population calculated during the year in which census was conducted. I think this was called the census year. And then we have the estimated population. It means the number of the population in any of the years between two censuses. It is obtained by application of different methods of estimation based on census data to estimate the number of population. Whether census or estimated, the number of population is usually referred to as mid-year population. That's an important term, by the way, which means the number of the population in the middle of a given year, the 1st of July. The reason why I say it's important is that off of like memory, like the top of my memory, I remember it being mentioned in every or most of the equations down there. Anyways, the first method is the natural increase method. Natural increase of population is the difference between number of life and death in the years which follows the census year. So for example, if we consider here that we have like a certain number of population in, for example, 2010. In 2011, we calculate the number of people who died and the number of people who lived, and like according to this calculation, we could predict the this year's census, I think, or like estimated number of population. Then we have the second method, which is arithmetic method. It's basically two consecutive census populations of a given area are taken, like for example, 200,000 in 1970 and 250 after 10 years. To calculate the estimated population in 1984, which is like 4 years after 1980, we should calculate the mean annual increase. So basically each year, how much is the increase? So it's gonna be mean. So it's gonna be the largest number, which is 250,000, as mentioned here. I will just rewrite it here so it looks a little bit more neat. Minus 200,000 over 1980 minus 70, which is 10. So it's basically like, in short, 50,000 over 10, right? Which equals to 5,000. Okay. That's the annual increase. So every year it has been increased by 5,000. Now, that's the first step. The second step, the estimated population 1984 is gonna be, because it's 4 years after the year 1980, so that's 4 years, right? So that's 5,000 four times. So it's basically 5,000 times four. And this number, which is I think 20,000, we added to 250,000, the year number in, no, I mean the census number in the year 1980. So that's gonna be like 20 extra thousand, and that's 270. That's the first equation actually. But how do we write it here actually? Huh? Do we just write the example, or do we write? Hold on, let's see. Arithmetic method. Let's try that first. Arithmetic method, and then it has two steps. Mean annual increase. Let's say first step, mean annual increase. I will just write here, second census minus first census over second census year minus first census year. Okay? And then second step, sorry, second step, estimated, what is it called? Estimated population. Which is from, like, based on this, focus with me here. Based on this is gonna be the second census plus open brackets mean, I'm gonna call this mean annual increase as MAI, okay, just so I save some space. So this I'm gonna call it MAI, okay? So it's gonna be MAI plus times, it's gonna be MAI times years increased. I'm gonna reference the page, which is page 7. Okay, just to revise, we have this arithmetic method. It has two steps. The first step is to calculate the mean annual increase. This step, we will take two census years. For example, 1980 and 1970, or 1980, 1990, whatever two census years, okay? The first census year, in our case, 1970, we had the population number of 200,000. And then the second year, 1980, we had the population number of 250,000. Now, we subtract the second from the first over the second from the first. So 250, our second population number, subtracted from the first population number, which is 200, over our second census year, which is to 1980, over our minus our first census year, which is 1970. Okay, now the numbers will be 50,000 over 10. When we divide that, we have our mean annual increase, our MAI, which is 5,000. Okay, now in the second step, we use this 5,000 to calculate the estimated population. What I mean by the years increased in this equation is our second census year, okay, which is in our case 1980. We add to this the MAI, which is 5,000, the one we found, multiplied by the years we want to increase. So for example, in our case, we're searching for 1984. So that's 4 years over 1980. So it's going to be MAI, which is 5,000, multiplied by 4. So that's 20,000. So we add 250,000 plus 20,000, that's 270,000. Why do we do the MAI plus the years increased? It's because if in 1 year we add 5,000, in 2 years that will be 10, in 3 years that will be 15, in 4 years that will be 20. We're estimating like how many will be added per year, which is why we also calculate the mean annual increase. That was really a mouthful, and I'm really sorry. It's a little bit confusing. Okay, now we have the third method, which is the geometric method. That's the most accurate method of estimation. Special formula is used to find out the annual rate of population growth to be applied to last census population to get the estimated population of a given year. So if a question comes, which of the following is the most accurate method, then we have to answer as geometric method. Okay, makes sense. Then we have the graphic method. I think this will be explained here better, but let's read what it has to say here. The graphic method, a number of successive census populations are plotted on a graph and joined together with a straight line, which is then extended over future years. Obtained graph can be used to find out two things: inter-census population, which is basically a given year within the inter-census period between two censuses, basically, or expected populations in the future years. So either something in the past or something in the future, on assumption that growth rate of the population will not change. This makes it a lot more not accurate as the before ones, because you're just predicting the future, which is not as accurate as it may seem. So in here, if, for example, we have the census year 2000, and we have the other census year 2010. Okay, in the year 2000 we counted in a population in Saudi Arabia was, I think, 20 million people. Okay, and in the year 2010 our population was 27.4 million people. Now if the question, it gives you this graph and it was like, give us the estimated growth in 2005, that's an inter-census year. So we go to here, like around the middle, that's where 2005 was. That was not a census year, that was inter-census, right? And then we go up here to meet the graph. And then from here, we go move like to the right side, and then that's our estimated increase, you know? So here it's around 24, 23 million. Yeah, of course, in the exam, it's going to be much clearer, but, you know, let's estimate it here around 23 million. Okay, now that's another important point, the population pyramid. The population pyramid, it says here, age composition of both sexes of population of any country can be presented in a pyramid made of numbers of horizontal strata. It's basically this one here. I'll be explaining it a bit better. Here we have like base, body, and apex. The base is people below the age of 15. The body will be between 15 and 59, and apex will be above elderly people, above 60 years old. Okay. It says here the shape of population pyramid varies in different countries according to the age and sex distribution of population, percent population of age of both sexes to total population. Basically, what it's saying here, it will vary between countries depending on which, like for example, in developing countries, their lifespan is a bit shorter than developed countries. So you find a lot less people on the elderly side of things. In fertile countries, you'll find the base a bit bigger than, for example, old countries that are not as fertile, like I don't know, like Japan maybe. So you could predict these stuff from the pyramid here. Now, if I go like a little bit closer here, if you notice, we have the numbers here between 0 and 15. So this area here, that's the base. And then up till here, that's the body. And then here, that's the apex. And then on the left side, we have the males. And on the right side, we have the females. Okay. Obviously here you could see that in the base or the like between the ages of 0 and 14 we have around the same amount of males and females, while for example here it's a pretty much equal. Maybe there's a little bit different at the age of 25 to 29, more males than females. Here you could see also a little bit equal, but you know, like in some countries, you might find more females than males, for example. Okay, so here we are going to talk about the characteristics of the population of Pyramid in Saudi Arabia, talking about the basal layer, the top, the body, and the sex distribution. In the basal layer, they say that the people below or the children below 15 years old are broad due to high birth rate, but lesser than the body. So the body is gonna be broader, and it says here that it's gonna be broader than the developed countries. Uh, in the top of the pyramid, it says here that it's narrowed due to small proportion of the elderly aged above 60, and in developed countries, top pyramid is flat due to higher proportion of the elderly. So it says here that what that means is basically they have more life expectancy than here. The body of the pyramid made of strata in between the top and the base, which is near to those of the developed countries. Okay, and then here it says the sex distribution between male and female ratio of the population shows insignificant differences, slightly more percent for males. So basically, there's a slight increase in the number of males over the females. Either way, here we have population growth. Two factors influence the growth. The main one, which is the natural increase, which is the basic factor. It is the difference between the live birth and the deaths. And then we have the migration, the minor factors, which is between immigration and immigration. Immigration is leaving the country, and immigration is receiving people from other countries. It may increase or decrease the population according to the extent of each. And also, those depend on like other factors that are not mentioned here. Either way, the takeaway from this slide is that the basic factor is the natural increase. Okay, rate of natural increase of population, RNI. It is the difference between birth rate and death rate, number of lives minus number of deaths in one locality and year, over the mid-year population of the same locality and year times 1000. Now, when I was first studying this, I had a very basic confusion with the wording, especially in the example here. It says 36 per 1000. So I'm like, when something or someone mentions per, usually what I think of is divided by 1000. But then after searching and asking several sources, I realized something. Here, we're not saying over 1000. Here we have the mid-year population. So if I'm going to give a better example so that we can understand it all together and revise it all together, if I have a population, a mid-year population of, let's say, I don't know, 200,000, okay? And then I said that I have in this like mid-year or this year, I had lost, let's say, uh, I don't know, let's say I gave like I had new births of 1,300 and I had 800 deaths, or let's make it 700 deaths. Actually, I want to even the number. Okay, I have a better idea. If I say I have 2,800 deaths, births, live births, and 800 deaths. Let's suppose, right? So my equation will be 2,800 minus 800 over 20,000. That will give us 2,000, obviously, over 20,000, which is basically 2 over 20, 1 over 10. That's 10th, 0.1, right? Now, that is, yes, as a number, like the equation tells us that it's accurate, but it's like confusing because we're talking about the number of people here. So if you're gonna tell me like a decimal, like 0.1, that does not make sense, right? So what we do is we multiply this number by 1,000, and it gives us 100 per 1,000. So my rate of natural increase of population, it is gonna be 100 people per every 1,000. So I'm increasing by 100 for every 1,000 persons. Okay. Here in the example, let me just erase all that. Let me just erase all that. Here in the example, what it says is the birth rate of 36 per 1,000 and death rate of 9 per 1,000 make the RNI 27 per 1,000. Okay, which is better presented as a percent. So RNI is 2.7%. Okay. The natural rate increase of the population in a high is high in developing countries as and eventually causes overpopulation problem, which is population crisis. Rate of natural increase, again, rate of the natural increase of population is high in developing countries. So there's more births than there are deaths. And eventually that causes overpopulation. So that will cause also population crisis, like problems due to overpopulation. But either way, we will just plot that on the on our little thing here. So I said that's RNI equals live birth over mid-year. Of course, we don't forget minus death times 1,000. And we can change that into a percent later. Okay? Now, let me just help you with a little trick I learned, especially that our exam application doesn't have a scientific calculator, unfortunately. To plot this in one single uh, equation, let's say, we will put the number, we'll first of all open a bracket, put the number which is live birth, minus death, close the bracket, divided by mid-year population. Okay? Now, you can multiply it by 1,000 straight up from here, or if you're scared that this can screw up with the whole equation, you could press enter, and afterwards, like whatever number you get, multiply that by 1,000. Okay? Either way. Vital statistics. Now, vital statistics is concerned with vital events of human life. So birth, morbidity, and death. So birth, disease, and death. Okay. It registered data are used for calculation and presentation of vital rates, which are indices, indicators of health status, community development, and effectiveness. So health status, which is of the population, especially vulnerable groups, the very young and very old, basically, I think. And then community development, including socioeconomic economic features which influences health, like for example, education, culture, nutritional status, environment, what affects the community as a whole, and then the effectiveness of the health service, so the efficiency and utilization of health service. Okay, birth fertility statistics. Okay, they are presented by birth rates and fertility rates. We first talk about crude birth rate, which is like the total. Definition: birth rate is the number of live births per 1,000 population of certain locality or country and year. So again, we're talking about mid-year population, but here we say birth rate equals number of live births over the mid-year population times 1,000. Okay, it's basically the same as before, but without the minus thing. So here, if we say crude birth rate, right? It equals live birth over mid-year times 1,000. Okay. Again, you could make that into a percentage later on if it's asked, but let's not deviate from the main topic here. Okay, now that was the crude birth rate. Now for fertility rate, a woman is considered fertile when she has ever born a baby. A number of fertility rates indices are calculated, each having particular significance. So first of all, we have general fertility rate, the GFR. This is the number of live births per 1,000 females in the childbearing period. So it's not over like the whole population this time, it's over the number of females in the childbearing period of their ages, basically. So it's between 15 and 49 years old. So here, that's the GFR. It's live births over. It was number of female childbearing times 1,000. And then we have the age-specific fertility rate, which is here we divide them. Okay, let's read the definition together first. It is total fertility of a particular age group of the 7 5-year groups to get the average number of live births born to 1,000 females in each of the 5 years of the age groups in a given locality. So we did agree that the birthing or the age of fertility or childbearing age is between 15 and 49, right? So we have a 5 age limit or groups. We divide it into those. So it's gonna be 15 to 19. That's one. Then 20 to 24. Then 25 to 29. then 30 to 34, 35 to 39, 40 to 44. So far we have 6, and we end it with the last of the 7, which is 45 to 49. Okay, these are the 7. So how the question will be is the same equation, but instead of giving it like the whole childbearing, we're asking for a specific number. So how many of the females are within the age group, for example, of 30 to 34, you know? So again, we have here to calculate the number of live births uh, per 1,000 in this specific group. Okay, so again, if we read it again, it is the total fertility of a particular age group to get the average number of live births born to 1,000 females in each of the 5 years of the age groups in a given locality. Okay, then we have C, the fecundity rate. It is the number of live births per 1,000 married women of the childbearing age in certain locality. It is a valuable index of fertility being calculated for married, not all females in childbearing period. So again, here we also have a different division. Instead of going through all the women in between 15 and 49, we pick only the married women of those, and then we calculate like accordingly to their like how many live births they have. That's for the fertility rates. Now, for the death or mortality statistics, again, the same concept here. Crude death rate is the total number of deaths over mid-year population of the same locality and year. So if we go there, actually, let me change the number, or not the number, sorry, the color and the size of these. We said here crude death rate. It equals to death, total number of deaths over mid-year population. Again, times 1,000. Here it's the same as the live birth, the crude birth rate, but instead of calculating the people who got birth in this year, we're calculating the people who died in this year. Okay? Okay. Specific death rates. Now, like we had specific live fertility rates or whatever, we have specific death rates. So we start with age-specific death rate. So here we're going to talk mainly about the infant mortality rate, which is, we have a lot of definitions here we need to remember and focus on. Okay, so IMR, or infant mortality rate, this is the infant considered an infant mortality rate is the baby in the first year of life. So from birth to 12 months. Okay, that's the infant, considered infant. Now this is like also broad in consideration to what we'll have later on. So this is the IMR, the number of the infant mortality rate, sorry. This number of deaths in infant over the number of live births times 1,000. Okay, that's not mid-year population, that's live births. So IMR, sorry, IMR equals to number of deaths in infants. We could say infant death over number of live birth. Don't forget times 1000. Don't forget the fact that we do have uh, like specific year, specific place. You know, we're not just taking numbers from this year and from that place randomly. We're specific year, specific place. But to shorten it here, I'm trying my best not to write many words. Okay. Anyways, so that's for the IMR. For the neonatal mortality rate, the NMR. Okay, what's a neonatal? Neonatal mortality rate is the number of deaths of infants during their first month. So from birth to the end of the last of the 4 weeks, sorry, per 1,000 live births in a certain locality or country and year. So again, NMR, neonatal mortality rate, is number of first month death, let's say, over number of live births times 1,000. Let's just add in the next page just in case you need it. Okay, now that's neonatal. What about post-neonatal mortality rate? Post-neonatal mortality rate is the rest of the infancy. So basically from the second month till the end of the year. So from 1 month, like after the month is finished, from 1 month to 12 months or 1 year. Post-neonatal mortality rate is the number of deaths of infants from 1 month to 1 year per 1,000 live births in a certain locality or country. It's the same thing. I don't know if I need to write it, but let's just say post NMR equals number of, I don't know, from of death. Nice. I wrote death wrong. Sorry. Death uh, between first and 12th month over number of live births times 1,000, I guess. Same concept, just different, different naming, I'd say. So it's not that hard, you know. Anyways, so okay. uh that's isn't yeah, that's the same abbreviation. I'm sorry. Uh, Perinatal mortality rate. Now, what's perinatal? The definition here says it is the number of deaths occurring in perinatal period between 28th week of pregnancy and the first week of labor or after labor per 1,000 lives born in a given locality or country. Okay, now, the first week of the neonatal life is considered a part of the perinatal period. So, if a baby is born stillbirth, basically he's born dead, or if he dies in the first week, he is considered or ruled under the perinatal mortality rate. It says here the first neonatal week is considered a continuation of intrauterine period. Thus, perinatal deaths, stillbirth plus death of the first week of neonatal period. Thus, the rate is an index of maternal care and early neonatal care. So basically, here what it says is the perinatal deaths is considered to be the stillbirth, again, baby born in born dead. That means he died like 28th week plus. Two, a baby who died in the first week of birth, the neonatal period. That is considered a perinatal death. Again, same concept. It's, let's just say perinatal. It's number of death between 28th. I'm gonna use a lot of abbreviations here. Week pregnancy and first week birth. Excuse the handwriting. Over number of live births times 1000. Amazing. Stillbirths, late fetal mortality. The definition here, stillbirth is a fetus delivered after the 28th week of pregnancy without showing any signs of life after being completely expelled from the mother. So yeah, he was born dead after the 28th week. Maternal mortality. Okay, now here's a tricky one. It's basically it's the statistics down there. We'll get to it. The definition here says it is the number of deaths of mothers due to causes related to pregnancy, labor, and puerperium per 1,000 live born in a given locality, country, and year. Here, what we consider, it's not over the mid-year population, it's not over the pregnancies, it's over the live births. So it's gonna be number of deaths, of mother deaths or maternal death over live birth times 1000. Okay, that's that's the tricky part. It's not over mid population, it's not over pregnant mothers, it's over live birth. You know what, we ordered already, let's just write it here. Maternal mortality rate, right? MMR. Great. Now, morbidity statistics. Morbidity are the incidence and prevalence rates on mortality of disease, which show the extent of spread of disease in the community. So here we're not talking about the death per se, we're talking about the disease itself, how many deaths it causes, how much is the prevalence, incidence, all that stuff. Okay, so now we move to the incidence rate. It says here incidence rate is calculated mainly for acute and sometimes chronic disease as well. It is the number of reported newly diagnosed cases of a particular disease per 100,000 at-risk population in a given locality or country and year. At-risk population, those exposed to the risk of a particular disease. For the majority of diseases, the general population is at risk, while in some diseases, a particular group only is the at-risk group. For example, okay, what I understood here is two things. Specifically for this like sentence, for the majority of the diseases, general population is at risk. So, for example, so here you could summarize it for by saying that most of the cases, if this comes as an equation, it will be asking about the general public and it will all be at risk. You know, for example, for malaria, for example, anyone is at risk for malaria. But the specific groups would be like, for example, I don't know, some disease that is complicated by, for example, immunodeficiency. So anyone with, for example, HIV or AIDS will be at risk. Or, for example, lung cancer, the people who are smoking are the at-risk population. This is the basic example I could think of. Now, the equation here, if I can understand it correctly, is basically the new cases over the at-risk pop times 100,000. I do remember that I read somewhere that you can use 1,002 here, but it says 100,000, so let's keep it that way, you know? So let's write it over here. Amazing. And now I think we move to the prevalence. Yes. Prevalence rate of particular disease. It is the number of total cases of disease diagnosed by conducted survey study in a certain locality, again, including all the new diagnosed during the definite period of time per 100,000 individuals. So again, it's like a similar thing, but here it's prevalence, so it will be both old and new. So if we put here prevalence, excuse any misspelling. Yes, it is all cases over surveyed patients times also 100,000. Surveyed or examined, both works. Okay, now mortality of diseases. Here we have like what, three? Yes, three. Mortality of diseases. Deaths of a particular disease can be represented in the following mortality rates. We have case fatality rate, mortality rate of a particular disease, and proportionate death rate. Let's start with the case fatality. It is the number of deaths of a particular disease per 100 cases in a certain locality or country. It's calculated by using this equation. The case fatality equals number of deaths of this disease over the reported number of diseases. I mean, of cases of this disease in the same year times 100. So, how I understand this is basically uh, we have, for example, 100 people, or let's say 1,000 people who sick with this certain disease, right? If we say, for example, 90 of them die, then it will be 90 over 1,000 times 100, you know, and that's it. So that's the that's the case fatality rate. CFR, I think it's called, right? Case fatality rate. Yep. Let's write CFR very quick. Do we have any other CFRs? We have GFR. Nice. Okay. So CFR, we agreed, is the number of deaths by a disease over number of cases reported times 100. Now, Next, we have the mortality rate of a particular disease, aka cause-specific death rate. It says here, mortality rate of a particular disease is the number of deaths of a disease per 100,000 population in a certain locality or country and year. How I understand it actually is that we're looking at how much death is caused by this particular disease, but instead of looking at it from a form of all the disease, this is like reported, this disease reported, looking at it as the whole population, you know. So how many smokers died over the whole population, you know? So the equation here, the cause-specific mortality rate, I would say could be death due disease or by disease, let's say, over to mid-year population or total population times 100,000. Let's say like that, you know? Okay, so let's write it here. It's cause-specific death rate, mortality rate of particular disease. Which one do you use? I think cause-specific death rate is better. It's a bit shorter. Or you know what? Let's try the one in bold. Of a specific disease, but I don't want to use the whole thing, right? So it's gonna be number deaths by disease over total population times 100,000. Hold on, that does not look like a good 100. Okay. Last slide here, proportionate death rate. It says here it is the percent proportion of the number of deaths of a particular disease to total deaths in a certain locality. So here, what we're focusing on is if we had, for example, 3,000 deaths this year, how much of those are caused by this specific disease? You know? So what we're gonna use proportionate death rate, proportionate death rate. It equals to death by disease over total death times 100 because it's a percentage, I think. Okay? I tried my best, honestly. Oops. Okay. In this question, I remember the doctor saying that it's like higher level, like to a point, to an extent where the equation that we're using is not even written in these slides. Frankly, if I remember correctly, it was the fact that we have 510 fasting hyperglycemia, and the onset is 45, the life expectancy is 70. So now we subtract 45 with 70, that's 25. And then I think it was to divide them, like divide 510 by 25. Oh, sorry. Uh, yes, 510 over 25, which will equal to 20.4, which is the closest to E. Either way, the doctor said it's not going to be this complicated, especially that the equation is not written and it has to do with the duration and whatnot. It's not written in the slides. Anyways, I do have a small gift, hopefully. The plan here is I will send the folder to Dr. Ihab to double check it. And if he agrees for me to share the folder, I will be sharing it with you. The folder is a little 30 questions I made about this one lecture, all equations, for practice purposes, you know. Uh, I did take by his advice and I did use some AI. And yeah, that's the folder. Okay. The folder has this style of questions. It's like short or medium length case scenarios with four choices. And at the very end, there's an answer key down there. Okay. If you want, I could solve like a random, maybe, I don't know. Let's try the first one actually. Okay, together. Question one. In 2010, the population of city A was 500,000. By 2020 census, it had grown to 650,000. A public health officer needs to estimate the mid-year population in 2024 to plan for vaccination logistics using the arithmetic method based on the mean annual increase calculated from the census date. What is the estimated population of the year 2024? So if you remember, if we go back to uh, our sheet here, if we use the arithmetic step, we have the mean annual increase, which is basically the second census 2020 minus 2010, also 10. And yeah, so it's gonna be like 600, sorry, 650,000 minus 500,000 over 10, right? Uh, See, it's like 150,000 over 10, right? And the annual rate will be 15,000. So each year we're increasing by 15,000. That's the first step. The second step now is we take the last one, which was 650,000 plus from 2020 to 2024, that's 4. So it's 15K times 4. A quick calculation here. We're adding 60K basically. So that here is 60. And we add it to 60, hold on, sorry, 650,000. So if we add them together, it's 710 B. And if we go down, B. Yes. Okay. All I have to say is good luck to all of you. I tried my best to help you. It is a confusing lecture, so I am sorry. And I am really, really, really sorry that I was late. It did take a while to be able to record all the parts. It is a very long lecture, and it did take a longer while to edit the parts. So I'm really sorry, and thank you so much for watching the whole video. And I really hope that I was a bit of help. See you, everyone, and good luck in the finals.